Hello and welcome back to a lesson 3.5, which is on page 55 in the spiral, and if you have the staple packet, it's on page 38. Spiral, staple. Oh, wait. Lesson 5, what happened to lesson 4? Yeah, we skipped that lesson. We might go back to it. Feel free to look at it if you got extra time. It's good stuff. It's just a little redundant and a little deep, and maybe we'll go back to it. Okay, so here we are. Parallelism preserved and protected. I'm going to try to make this extra entertaining. How would you complete the following statement? Two lines in a plane are parallel if... You could say if they never touch, but, well, if they're in a plane, I guess that works. Just if two lines don't touch, that doesn't mean they're parallel. They might not even be in the same plane, which means like one could be on the ceiling and one could be on the roof. They'd be in parallel planes, though. Interesting. They stay equidistant. What else? They have the same slope on a coordinate plane. Wow, my handwriting is terrible today. What's going on? Must be tired. Coordinate plane. Big holiday party today for the staff. Wow. Oh, maybe I need more coffee. I'm going to pause right here and go get some coffee. Okay, I'm back and ready to rock. We're going to determine when a line will be parallel to its preimage after translation, rotation, reflection. Build a system of geometry based on definitions, postulates, and theorems. Remember, postulates are accepted without proof. People just agree that they're right. There should be obvious things. Obvious, agreeable, everybody likes that. And theorems are provable. They could be less obvious. They could be like really complicated, but step by step provable. Theorems are provable. Postulates have to be simple. Almost universally. I don't think there's any complex postulates that wouldn't be a postulate. In a previous task, how do you know that? You might have wondered how you knew this figure, which was formed by rotating a triangle about its midpoint of one of its sides, was a parallelogram. How did you know? How did we know that was a parallelogram? You may have found it difficult to explain how you knew that sides of the original triangle and its rotated image were parallel to each other, except to say it just has to be so. Well, we said after 180 degrees of rotation, a horizontal line is back to being a horizontal line. I mean, that's kind of a bit of that's the postulate. After 180 degrees of rotation, a line is either coincidental with itself or parallel to itself. But whatever. There are always some statements we have to accept as true in order to convince ourselves that other things are true. We try to keep this list of statements as small as possible and as intuitively obvious as possible. For example, in our work with transformations, we have agreed that distance and angle measures are preserved by rigid transformations, since our experience with these transformations suggests that translating, rotating, and reflecting figures do not distort the images in any way. Okay, so we're saying rigid transformations, the reflections, translations, and rotations, rigid transformations. What's their claim exactly? Oh yeah. Preserve distance and angle measures of an object. Nothing in our experience has ever led us to not believe that. We can kind of accept that as true. Yeah, if you move something around without changing a shape, it'll keep the same shape. Okay, we agree. Likewise, parallelism within a figure is preserved by rigid transformations. For example, if we reflect a parallelogram, the image is still a parallelogram. The opposite sides of the new quadrilateral are still parallel. Mathematicians call statements that we accept as true without proofs postulates. Or axioms is a cool old term. Statements that are supported by justification and proof are called theorems. Knowing that lines or line segments in a diagram are parallel is often a good place from which to start a chain of reasoning. Almost all descriptions of geometry include a parallel postulate among the list of statements that are accepted as true. In this task, we developed some parallel postulates for the rigid transformations. Translations. Under what conditions are the corresponding line segments in an image and its pre-image parallel after translation? That is, which bird best completes a statement? After a translation, corresponding line segments. That means a chunk of the pre-image corresponding to it, that same chunk in the image. After translation, corresponding line segments in an image and its pre-image are do 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 do